Today I'm going to discuss about encryption and decryption in Python, and also I will show you some demo after a few slides. The first question, what is encryption? So encryption, which is an important thing which we generally use to converting the data into the ciphertext. Basically we use the encryption for the sensitive data. Encryption is the process of encoding the data, that is converting the plain text into the ciphertext. So if you think like what is the type of ciphertext here? Ciphertext is converted data through the encryption process. This conversion is done with a key called as encryption key. And as you see in the diagram, you see that there is a plain text data and you are using some algorithm, encryption algorithm, converting that one into the ciphertext. So then what is the decryption? It is a quite opposite to the encryption process. You have the ciphertext, that is the encrypted text, which you are decoding. The process name is called decoding and to the plain text data. So decryption is the process of decoding the encoded data. So in other words, we can say converting the ciphertext into the plain text. This process also requires a key that we use it for the encryption. So next one is, there are two important keys we use in the encryption algorithms. The one is symmetric key, the another one is asymmetric key. Then you will have a question now, what is a symmetric key, what is asymmetric key? So let's talk about now what is symmetric key. So symmetric key, which is basically we can use it for both encryption and decryption, means the data which is encoded and decoded with the same key. This is the easiest way of encryption but also less secure. And now question comes, what is the asymmetric key? The asymmetric key is actually, we use the two keys here for public key and private key. The public key is used for encryption and the private key is used for the decryption. So basically encrypt the data, decrypt the data. So basically in this asymmetric process, we use the two keys. And what are the Python libraries we can talk about encryption and decryption? So these are the list of Python libraries we can use for the encryption process, and there are other libraries also, but those libraries we can discuss in the future. Right now I displayed the three important libraries. One is Pycrypto, Cryptography, RSA. Just you can look at this first one. This is very powerful library which has all the types of encryption algorithms. And also second one is cryptography, which is mainly we can use it for the symmetric encryption process. That's where you use only one key. In cryptography, there is a submodule name is called the fairnet, so which we are going to use it for the entire encryption process. RSA, which is also supports the encryption and decryption, and mainly we can use it for the asymmetric encryption process. That means you are going to create two keys here. One is public, another one is the private. Let's do the coding and we'll understand much more better on this topic. Okay, let's get started with symmetric key or symmetric encryption process. So I created one folder here is encryption. Inside that there is one file that's name is called symmetric_01.py. Here I'm going to start coding, and before that we need to install the cryptography. Hit 3 install cryptography. Just enter and it will install. So in my case it is already satisfied because already installed in my system. So let's do the coding now. From cryptography, so this is the main module, and import. Before going to import, we can directly take the class, so we can use the submodule name is called the fairnet. Under that, there is a class name is called the Fernet, and this is the class. Okay. And after that, we'll take very simple text here. I can say that message. So the message is like anything which you take. I'm just taking hello. Uh, Hello, I am Pythoner, or I am Python, which I'm going to take. So I want to convert this message into the encrypted format, but before that we need a key. As I said that this is a symmetric process, a symmetric encryption, we need a key basically. So Fernet, which is a class, and there is a method, okay, generate key, which we are going to use, and this key, okay, basically will generate the value. So basically this is going to generate the key, because a print of key, and I'm going to run and show you that what is the value. You can see the key is in the binary format, which we got it now, right? So now what we can do, right, let me increase the font size that you may see little bigger now, right? So what we can do, right, I'm going to use the same key for the encryption and decryption. So first, let's use the Fernet, okay, and dot Fernet. Okay, we need to create a key, right? This key. So key dot and encrypt. So basically, I'm going to use the same key for both encryption and decryption process. So basically, before using this key I need to pass to the first Fernet. Okay. So let me pass. Take this is the class. Okay, and this is a constructor. I'm creating an object for this Fernet class. So I will pass the key as an argument. Okay. So then we can say this the variable name or object name here. We can use the Fernet, okay, or we can fernet obj we can mention, so just for understanding purpose. Okay, so what we will do right now, this by using this object I can call the both encryption and decryption methods. So for example, now you can see there is an encrypt fernet object, right? Fernet object dot and decrypt. So these are the two functions or two methods are available on the Fernet object. We can call this. So encrypt, this method basically accepts the message. Okay, it means that some text which you want to encrypt, message dot, and we can do the encode. This value basically we are going to pass. This is actually a encrypted. Okay, so encrypted message. So we can say that encrypted message. If you want to see this output, okay, let me reduce this size. Okay, if you want to see the output of this, you just simply use the print statement encrypted message, and this I'll put into the comment section. Now I'm going to execute this code. You see that there is an encrypted text data which is showing up on the screen, right? So you can see that there is an encrypted text message which is showing on the screen. So one is the key, another one is the value, right? So that's how it is. We can create encrypted message. And if you want to decrypt this message, okay, fernet object dot decrypt, and this decrypt will take the already you encrypted message. Okay, already you have encrypted, right? So that encrypted message dot and decode. So what I will do, right, encrypted message dot, and we can use the decode function, and this is going to be a decrypt message. So let me write here. So I will say that this is decrypted message, and if you want to print this, okay, and we can use the print statement, print of decrypted message, right? Now if I go and execute this code, you can see that, okay, there is an error here. Token must be in the bytes. Token must be in the bytes. So what exactly is happening here? Because I did small mistake here. So decrypt of, you have to use the encrypt message inside this, and this is the way, like if you go and execute now, you see that output is hello I am Python. Are you little confused with this terminal at the right side? Let me move to the down. Okay, I hope now it is useful, right? So now we can see, so this is the first b byte, which is in the form of bytes. Okay, that is for the encryption key. Another one is for the like text data which you are encrypting. So this is a whole like encryption and decryption which we can do with the same key. We are using the same key only we are passing to this class. So class is actually is encoding and decoding, both are performing. Now you want to send this code to the file. Okay, for example, you want to send this encryption to the file. So we can use with open, and so mention some file name is like test.txt, and after that you just open the mode is W. So please observe here, I'm just opening this file with the W mode. Let's see this what is going to happen, right? So I will show you some error, because it won't generally open the W mode because you are sending the encrypted data. So encrypted data, it is not like a normal data, right? It's like completely byte data. So definitely we need to open with the WB form mode, but I'm just opening with the W, and you will see the error now. So I want to write this the encrypted one, so that is called encrypted message, to the file. Let me go and execute this code, and you see that write argument must be a string, not the bytes. So you need to convert this one into the WB mode, then execute the code. Now this is done, but we need to see the file. So now I'm going to click this test file, and you see that there is an encrypted message in the file. So we can send this to the different files. Okay, not only the text file, different files which we can do it. So this is about, so again I'm repeating, there is a message and there is a key. That key, by using that key we are creating an object. By using an object we are calling the encryption method and passing the encode method, and decryption, again decoding, and finally we are sending this data to the file. So it is not only this one, we can also do it with the multiple ways. For example, here I have only one message. What if I have these messages into the list? So that is also I can show you now. Now let me show you that symmetric encryption process with the list of strings. So if you can see guys, in the previous example, we already deal with one single message, that is a string, and we encrypted and decrypted. But if I have a requirement like a group of strings within the list, how to do it? So this code is already I created, because I don't want to make it this video as lengthy. So there is a messages here, and hi, hello, greetings, these are the strings, and same process whatever we have done in the previous example, right? So we can use a fernet, generate the key, and key will be generated. Same key I can use for the multiple strings here. Okay, so here I am using the list comprehension. So this list comprehension with a single time, like so each and every message I am going to read, right? These messages is the list. I will read each string from the messages. That each string I will convert into the encoding. That encoding I will give it to the encryption process. So finally this will be encrypted. All these three, hi, hello, greetings, will be encrypted. So here I am printing the original string, encrypted string, and also we have the decrypted messages here. This decrypted messages, again I am doing the list comprehension to decrypt the each and every string here, right? So again same process. So we have the encrypted message, this is a list. That list I am reading the each encrypted message and decrypting by using the decrypt method, right? So finally this decrypt string which is going to print it here, I am sending to the file. Just remember previous example we used the write function, but here I am using the write lines. Okay, now I'm going to execute this code, and you see the output of this functionality. The first one is the key, and the key which is created here, that is the fernet key, and I'm going to use the same key both for encryption and decryption. But thing here, I have the multiple strings, right? You see that there is a list. The list is created with the multiple strings, sorry, multiple encryption keys here. Okay, sorry, multiple encryption values are created in the list. Okay, that's how it is. And finally, decrypted string is there, hi, hello, greetings, which you are seeing it. And if you want to see the encrypted data into the file, we can say it. But I am not separated by the comma. We can also do it by little adding some extra functionality. Okay, this is the symmetric encryption for the list of strings. And also, we are done with the encryption process for the a single string. Now, I'm going to talk about the asymmetric encryption process. There, I'm going to use the RSA. So, before going to start asymmetric encryption, so we need to first install the RSA. So, that is a separate module which I'm going to install now. So, the command is pip3 install RSA. Just enter. So it is already satisfied in my system because it's already installed. I worked on it before. So I'm going to import RSA, import RSA, and we need a simple text here to which we can migrate. So which we can encrypt basically. So message is equal to say that hello, I am Python. This time I'm not going to use the single key. I'm going to use the two keys. One is for public, another one is for the private. Okay, so first let's generate the keys here. So RSA is the module. From the module we have there is a uh, function name is called the new keys. Here we can pass the 512-bit encryption process, and this is going to generate the two keys for us. So one is the public key, we can say, so that's something we can mention here. So another one is the private key, so that's something which we can say here. So public key and private key. If you want to print this public key and private key, just use the print statement, and I'm going to print this public key and private key here. So just execute this code. You see that this is got printed. Now after that, okay, we can use the same, okay, we can use the RSA. The RSA is the model which has both encrypt and decrypt functions. So when you are going to encrypt this, we have to use the message, and message dot and encode is the function. This is all. This is called like encryption. So encryption message or encrypt message, whatever it is. Now I want to print and show you this. Okay, what is the encryption message here? So you will see the both the public key and private key and encryption, right? Okay, so yeah, this is a very important. When I'm going to encrypt this, I'm missing something called public key. So when you want to encrypt here, because it is the RSA, because you are using the asymmetric process, so basically you have to give the public key. Now if I'm going to execute this key, if execute this code, then this is showing the output. So if I want to decrypt this code, it's very simple. So use the decrypt. Okay, I'm going to change the name called decrypt here, and instead of encrypt we can use the decrypt, and instead of the decode we can use, instead of encode we can use the here decode function. Okay, so message dot decode. Okay, but remember guys, if you use the message dot decode, this is going to throw an error. Okay, basically this is not the way. So we have to use the encryption message, not the message, right? Use the encryption message, and after that private key which you need to pass, and this is going to be decode by using the decode function, and you can print the decrypt message here instead of the encrypt. So now you can go and execute this code. Absolutely, this is giving the actual input string, right? So this is basically we are using the two keys here, private key and public key. So you remember here public key which I am using for the encryption process, private key which is whenever you need decryption, then we can use the private key. Okay, which is a very important guys. If you want to, you can read the here description is considered failed when the resulting clear text does not starts with the bytes 0002. So you have to go to their documentation, read much more about, but I'm just giving the idea about encryption and decryption, what are the modules, how to start. But in future I'm going to talk many more other modules. Hopefully you are liking this content, so I will connect with you in the next video on the different topic. Thank you.